In this lesson, we're going to talk about the elasticity of demand. The measure of the sensitivity of demand changes in price is called elasticity, and it's measured as a percent change. The elasticity of demand for a product is the ratio of the percent change in demand to the change in the price. So the elasticity is equal to the absolute value of the change in demand divided by the original demand over the change in price divided by the original price. We can rewrite this complex fraction a little simpler as the original price divided by the original demand times the change in demand over the change in price. If my elasticity is greater than 1, then my demand is elastic. That means that the demand is sensitive to changes in price. If my elasticity is less than 1, that means that we're inelastic, so the demand is not sensitive to changes in price. If my elasticity is equal to 1, then we have what is called unit elastic. That means the percent change in price and demand are equal. So suppose the price of a product increases from $9 to $10 and the demand drops from 150 units to 110 units. Find that elasticity of demand. So using my formula, and again, I'm going to use the simplified version because it's a little easier to work with. The original price is $9. The original demand is 150 units. The change in my demand was negative 40 because I dropped from 150 down to 110. And the change in price was positive 1 because we increased from $9 to $10. When I simplify this, I get 2.4. So since 2.4 is greater than 1, that means that the demand is elastic. So it's sensitive to changes in price. If we increase the price by 1%, the demand drops by 2.4%. The price to an athletic event rose from $45 to $50. Average attendance dropped from 18,500 to 17,600. We want to find the elasticity of demand. So my original price was $45 and the original demand was 18,500. Our demand dropped by 900 attendees because our price increased by $5. When I simplify this, we get 0.438, which means that our demand is inelastic. So increasing the price by 1% drops the demand by 0.438%. We know that demand isn't always given in exact numbers. Sometimes we're given a demand function. So to find the elasticity of demand of a function, we're going to take the original price still divided by the original demand, and we're going to multiply it by the change in demand, which is just going to be the derivative, since we know that the first derivative is the average rate of change of a function. The demand for a product is given by this demand function where P is the price. We want to find the demand elasticity at $7 and $11. So in this example, I'm going to show you how to find the elasticity when we have a price of $7. You can try to do it for $11 on your own. So my price is $7. My quantity, so plugging in that price into my demand function, is 200 units. And my change in demand, which is the first derivative, when I plug in again that price is 7, is going to be negative 15 units. Plugging that into my formula, I get 0.525. So if the price is $7, the demand is inelastic. So a 1% increase in price creates a 0.525% drop in demand. Lastly, we have the elasticity of demand and revenue. So from the previous course, you should know that our revenue function with respect to price is just price times the demand function. So if my elasticity is greater than 1, we know that the demand is elastic, so the revenue is going to be decreasing. However, if my elasticity is less than 1, then our demand is inelastic and the revenue will be increasing. If I have something that is unit elastic, if my demand is unit elastic, then the revenue is not increasing or decreasing. So that means that's where I'm going to hit my maximum for the revenue function. What that means is to increase the revenue, we're going to raise the price if my demand is inelastic and lower the price if my demand is elastic. So demand for our product is given by this function. What is the maximum revenue? Well, the first thing that we need to figure out is what's the revenue function. Remember, revenue is just price times demand. So I multiplied that out with the demand function. So I have my original demand function that I was given, and I found the revenue function. I know that the maximum revenue is going to occur when the elasticity is 1, which also means that the first derivative of the revenue function is equal to 0. We know this from the first derivative test. We know that a maximum is going to occur when I have either the first derivative equal to 0 or if I have an undefined value that comes directly from the first derivative test. So I'm going to take the first derivative of my revenue function, set it equal to 0. This ended up just being a nice quadratic function, so I factored. And I'm left with here p is equal to 6 and p is equal to -2. Now we know that price can't be negative, so I'm just going to ignore that result. And that means that the maximum revenue occurs when the price is $6.